Interplanetary File System (IPFS) is a protocol and eponymous network designed to create a content-addressable, peer-to-peer method of storing and sharing hypermedia in a distributed file system. IPFS was initially designed by Juan Benet, and is now an open-source project developed with help from the community. In 2014, the IPFS protocol took advantage of the Bitcoin blockchain protocol and network infrastructure in order to store unalterable data, remove duplicated files across the network, and obtain address information for accessing storage nodes to search for files in the network. Implementations in Go and JavaScript exist, and a Python implementation is in progress. The Go implementation is considered to be the reference implementation while formal specifications are developed. IPFS is a peer-to-peer distributed file system that seeks to connect all computing devices with the same system of files. In some ways, IPFS is similar to the World Wide Web, but IPFS could be seen as a single bidder and swarm, exchanging objects within one Git repository. In other words, IPFS provides a high-throughput, content-addressed block storage model, with content-addressed hyperlinks. This forms a generalized Merkle-directed acyclic graph (DAG). IPFS combines a distributed hash table, an incentivized block exchange, and a self-certifying namespace. IPFS has no single point of failure, and nodes do not need to trust each other, except for every node they are connected to. Distributed content delivery saves bandwidth and prevents DDoS attacks, which HTTP struggles with. The file system can be accessed in a variety of ways, including via Fuse and over HTTP. A local file can be added to the IPFS file system, making it available to the world. Files are identified by their hashes, so it's caching friendly. They are distributed using a bidder-based protocol. Other users viewing the content aid in serving the content to others on the network. IPFS has a name service called IPNS, a global namespace based on PKI, serves to build trust chains, is compatible with otherness and can map DNS, onion, bit, etc. to IPNS. Every Merkle is a directed acyclic graph (DAG) because each node is accessed via its name. Each branch of Merkle is the hash of its local contents, naming children by their hash instead of their full contents. So after creation there is no way to edit a node. This prevents cycles, assuming there are no hash collisions, since one cannot link the first created node to the last node to create the last reference. In general, for any Merkle to create a new branch or verify an existing branch, a hash algorithm is used on some combination of the local contents, such as a list of child hashes and other bytes. A few different hash algorithms are available in IPFS. The data input to any of those hash algorithms is documented. The Catalan independence referendum, taking place in September-October 2017, was deemed illegal by the Constitutional Court of Spain, and many related websites were blocked. Subsequently, the Catalan Pirate Party mirrored the website on IPFS to bypass the High Court of Justice of Catalonia order of blocking. IPFS is being used to create a mirror of Wikipedia, which allows people living under repressive regimes to access the content of Wikipedia.